Okay, so here is a composite beam design example. When you set up the loads and load combination, you will be able to really run composite beam design. So we're going to take it as a default and hit the start design check. So ETABS will show the beam size and number of studs. Since beam is relatively short, 24 feet, I think we don't need a camber, but let's select one of beam and right click, so you'll see the whole table. The beam on the left is all workable size, right? The beam size, the heavier it goes down, see obviously stress level is getting lower. The number of studs that beams just require only minimum. Those all section is in this A composite beam group, so they are just all listed down. Also, strength check and deflection check is shown here, right? So strength check, you see the construction bending. This is based on phase 1, the load, 1.4 dead, 1.2 dead plus 1.6 construction live load. So maximum bending is 51.3 kfoot. This bending should be reduced by the pure steel section. After concrete cure phase 2, now this is the example of W12 by 22 with the number of studs, which actually provide some partial composite action, and their bending capacity is 179 versus their permanent bending moment under 1.2 depth plus 1.2 depth superimposed dead load plus 1.6 live load, which is smaller than just capacity. So this is just capacity check. And then deflection check is happening here. So you see that pre-composite deflection is just pure steel deflection based upon the width of concrete. You see that 1.7 inches, right? Post-composite dialogue deflection is based upon just composite beam, which is concrete slab and steel members. Those are composite like a T-section. So based upon number of shear stud and composite action will be determined. And since the composite action is determined, the I moment of inertia will be calculated based upon two material, and they calculate the deflection under superimposed dial load plus live load. See, that's post-composite action deflection. And live load deflection is straightforward. Live load deflection is 0.3 inches based upon the live load and with the composite beams, which is determined based upon the concrete and steel, their combined stiffness. So here we're checking that live load deflection 0.3 inches, which should be less than our criteria L over 360. L is 24 feet times 12 divided by 360. That is, I think, equivalent to 0.8 inches. So it should be less than this. We're okay. Total deflection here is show 1.8 inches, which is our criteria is L over 240. So length 24 feet times 12 divided by 240. So both are all less than our criteria. So this beam, the lightest beam, W12 by 12 by 22 with 8 number of studs, I think it will work. So the ETABS show the number of beam size, number of studs. If we design the longer span, obviously deflection is relatively bigger, and the ETABS might show the beams with number of studs and show the camber. So we'll see in other example.